Welcome to the project demonstration of battery management system with active cell balancing. So here the main application of this system is we are doing the active cell balancing. That is nothing but whenever we are using 3 battery packs in a system, nothing but in a EV vehicle or anywhere from the battery power, then in that one, so if any battery voltage is low level comparatively with remaining battery cells. For example, so coming to the, here we are using 3 battery cells, battery 1, battery 2, battery 3, and whenever the battery 1 voltage is less than the battery 2 or battery 3, then the higher voltage level of the battery pack will be connected into this lower level battery pack with help of this electromagnetic relays to transfer the energy which is higher than the battery pack levels. Means, for example, if it has a 2.5 and 3.5 and 4.5, then the 2.5 is a low battery voltage will be connected to the higher voltage 4.5. Then the voltage will be transferred from the higher battery voltage levels to the lower battery voltage levels, and then when these two are equal, so means the remaining voltage, so 2.5 and 3.5, then 3.5 is the 2.5 to 4.5, then the voltage levels is going to be the 3.5 till that reaches the system connected these 2 battery packs in parallel. So when these reach to 3.5 volts, that is nothing but it's also the voltage decreases from 4.5 to 3.5. Then these two are 3.5 volts, and the remaining is all 3.5 volts. If it is 3 volts, then the higher voltage battery levels will be connected to this battery pack again to make the 3 battery packs into the same level. Means all should be the same voltage level. Till that the system keep on connecting the battery packs parallelly. So right, for this approaching, we are making use of a PIC microcontroller which is continuously measuring the voltage levels from this battery cells continuously. So we are using demonstration purpose 4 volt 1 amp battery cell. We are using totally 12 volts of battery, but separately we are measuring that, and individually the system will connecting the battery packs using this electromagnetic relays. And these are the switches to isolate the power supply to the microcontroller in order to provide the low battery alerts. As we are using the fully charged battery packs, that's why it will measure the continuous voltage. But in order to show the active balancing to on the electromagnetic relays, we should provide the low battery alert to this microcontroller. That will be done with the help of the switches by isolating the voltage levels to the microcontroller. So we have interfaced these voltage sensors from this one directly to the A0, A1, A2 pins, and B2 to B7 for this relays, C5, C6, C7 for this electromagnetic relays. The main power input is 230 volts AC input that is parallelly to the transformer which is a step down transformer which will take 230 volts AC input and provide us 12 volts of AC output, and that is nothing but a regulated power supply section which will use it to convert AC to pulsating DC, and the pulses will be removed with help of this filter. Will get the pure DC, that is 12 volts, and the operating voltage of our system is a 5 volts. So for that purpose we are using the 7805 voltage regulator which will take 12 volts DC input and provide us a 5 volts DC output. So that is operating voltage. From here we are providing that to the microcontroller, and this is the parallel getting 230 volts which is the regular power supply board to charge our battery packs through the switch. This is the external charger whenever the battery is totally drained. So if we are drained in between these battery cells, using these relays we are going to do the active balancing. But if the total batteries are drained, with the help of this switch we can charge a battery pack directly. And here so this switches directly interface to the between the battery cells and the microcontroller. So let us see the demonstration just on the power supply. So initially we isolated the power supply as when we on this, the system getting power supply, that's why it will system won't get off. So now we are directly on the 3 batteries at a time. So we can see the battery voltages. Battery 1 is 4.1, battery 2 is 4.1, battery 3 is 4.1. So if I isolate the battery 3, means we are making the battery 3 voltage is low, means 0 volts. Then as of battery 1 and battery 2 are same voltage levels, that's why it will take any one of them. So that's why it took the battery 2 and connected the battery 3. So now these two are connected in parallel with the help of this relay. This relay connected these two one, and when it is coming to normal, the relay will be off in same levels. And again I am isolating the battery 2. Now battery 1 is transferring the voltage to the battery 2. As we can see, the 2 relays got switched on to maintaining the battery transferring voltages. And next, so now only the battery 1 is getting voltage from this battery 3 pack directly, right? So in this manner the battery voltages will be active balanced with help of this electromagnetic relays by the microcontroller.